So, interesting topic for this afternoon, I believe. I chose ESG and opportunities for robotics in a circular economy. I think ESG is a very hot topic. So, environment, social, and governance. Targets have been set. Many companies now are trying to roll out their strategy related to ESG, especially companies who are involved in exporting their products. It will become more and more of a requirement from customers outside of Malaysia to show that you have a program in place in relation to ESG and you have traceability as well. So what I will do this afternoon is just go through the implication of ESG in robotics, what we do at ABB in that regards for our own operation, and then what you can do as customers of ABB in your own plant operating robots. A lot of what I say this afternoon is not only about ABB robots. If you are running other robots, it's applicable for the robots as well. So it's more of, let's say, an educational talk on ESG and robotics in circular economy. So you might all know this little fellow, Wall-E. We took these pictures because Wall-E is a robot that has survived the end of the world, is surviving on collecting spare parts and repairing things for many, many, many years. And so Wall-E is a little bit of an example as to ideally what you should be able to do in terms of circular economy, keep recycling things and continue operating without using new resources. So as I mentioned, we will look at it from a robot's life cycle perspective in general, what ABB is doing in terms of its operation, then energy efficiency of the robot in general, and finally, what can be done in the servicing stage of the robot. So for the robot life cycle, first it starts with mining. So again, remember that if you're looking at circular economy, you have to look at the entire spectrum of the life cycle of an equipment, whether it's a robot or a car or something else, which starts from mining for raw material. A robot is a big, heavy machine, has a lot of metal, and that starts with the mining operation. So collecting raw materials for the manufacturing of the robot arm, all the process of transforming the minerals into metal, so forgery and so on. Transport. So we're all talking about carbon footprint here. So what do you need to extract? What do you need to transform? What do you need to transport? And this is transporting raw material or prefab material to our own manufacturing facilities. Then comes the ABB own operation. So what do we do in our own factory in terms of carbon footprint, or analyze what is our carbon footprint and what can we do about it? Once we have the finished product, we move to transport again. So that's transport to end user or transport to a system integrator. Then you have the actual life cycle, the lifetime of the robot at its final destination or pre-final destination, I would say, during operation. And finally, 15, 20, 25 years, we have some robots that have been a very long time in the field. You will be considering the servicing, the end of life of the product, the end of life of the robot, and what to do about it. So if you look at the life cycle of a robot in terms of CO2 emission from the different categories that I have mentioned earlier, there's a little bit of a quiz here, or question mark. You can think about it. In which area do you believe the robot has the highest CO2 or carbon footprint during its lifetime? I'll leave a few seconds for you to think about it and then see if you are right. If we look at it, the use of the product at the customer side, this is the highest carbon footprint that you will have for a robot. Now, we have to mention here that the dimension of this bar here can change if you are operating in Europe, where there is maybe more renewable energy from solar, from wind, or hydropower, whereas if you're operating the robot in a country that is mostly using coal-fired plants, that energy, the consumption of electric energy produced with coal fire would have a larger CO2 footprint than you would have if you use hydropower, for example. So as a company, what you can already do in terms of energy sourcing, and it's starting slowly in Malaysia, is to look at sourcing power from green sources or renewable sources. TNB starts to have programs like this where you can select where your power is coming from, and you will already be able to act into this long bar here. Another way to reduce this, and we will talk about this later, is to reduce the energy consumption of the robots itself. So one is to see that you source energy from a source that is renewable. That will in itself reduce the carbon footprint. And the other one is to see that you consume less energy during the lifetime of the robot. So for ABB's operation, basically, we are in this area here. So of course, that falls under us because we purchase this raw material. So we have to see that in our purchasing processes, the footprint can be reduced as much as possible, as well as during the transport, during production, and again during the transport after the production. So you look a little bit as to what actions we are taking in that regard. Here you see the targets in terms of energy consumption at our own facilities. For Malaysia, you might be a little bit surprised to see heating, but our factories are located in the northern hemisphere. It's cold in the winter, so it requires heating, and hence we need to see that we can reduce the consumption of power for heating up our manufacturing plants during the winter. Then electricity consumption in general, as well as the type of vehicles that we use. So at the company-wide level, there is a commitment from ABB that we will be switching all our fleets of vehicles to EV vehicles by 2025. So here you can see that over the years, with a benchmark in terms of CO2 emission in 2019, we are planning to reduce this very significantly, and we have already made a lot of progress in that regard. So that goes into walking the talk in regards to circular economy, but within our own operation. So what we can do within our own operation. So for example, making sure that you have renewable green energy coming in, installing solar panel on the rooftop of the factories is a contribution to this. Here we are also using a heat pump. This is a way to heat the factories during the winter, which consume less energy. And so we are talking about the tip of the iceberg here. That's what we have under control as a manufacturer for robotics equipment. Suppliers' emission here, that's not directly under our control, but it can be if you make sure that your supply chain managers are doing right work in analyzing and auditing your suppliers and asking the questions related to how they themselves look at circular economy and how do they make sure that they reduce their carbon footprint. You will be able to also have an indirect effect on the supplier's emission by forcing your supplier to adopt methods of transport, of productions that are consuming less energy. So you can do it through these methods that you see on the left side of the screen. Now, for energy efficiency of the robots themselves. So you remember that this is by far the largest, the biggest portion of energy being confused and consumed, not confused, and the CO2 footprint. So here you can affect this with the technology that you use. And what we have here as example, it's a comparison between our previous generation of robot controller, the IRC5, and the new generation of controllers, OmniCore, that have a built-in function that allow us to go and have up to 23% less energy consumption. And that goes into a different way of doing things. One is what we call regenerative braking. So instead of dissipating the energy of the robots when the robot moves and you want to slow down, dissipating that energy into brake, basically eat, you regenerate, so you recapture the energy from the robot when the robot is slowing down with the payload, and you send that energy back to the network. So that's one way to do it. The other way is to see that you have a careful planning of the robot path. Now, it's not very visible, but if you look at the red line here, it's quite squarish and rough in terms of trajectory versus what you see here. So if you're looking at moving a part from this point to that point in a squarish way, a very rough way, the robot will accelerate and decelerate a lot. And doing it this way will have a higher energy consumption. Whereas if you give sufficient space to the robot arm to have a nice gracious movement, that's the path that you can see here, you will be able to come to less energy consumption. So you can see here in this example, if you move the part along this path, you will consume 3.6 kilojoule versus if you program the path in this nice round shape, you will be at 2.3 kilojoules. So that goes into direct energy savings during the lifetime of your robot. And here, we are only talking about one cycle. Of course, the task of the robot is to repeat this continuously forever, unless you change product. So this is a direct, very large impact on how much energy the robot will consume. How we are doing this, what you can see here on the screen, this is a snapshot from our programming software, simulation software that we use called Robot Studio. And we have built in that function that allows us now to also consider the energy consumption as part of full and entirely part of the robot programming itself. Now, at the end of the day, a lot has to do with how the user is approaching this. If you have engineers in the field that have been trained and are conscious about the impact of what they do in regards to energy consumption, they will have this in mind when they program the robot. They will consider this and have a check at how much energy is actually being used for each cycle. Of course, if that training and that understanding is not there, you might still end up with a solution where the robot is actually consuming more energy than it should. So what you can do as a customer, automatic path planning, that's what I just mentioned. So that's basically planning it in an energy efficient way in our simulation software. In terms of reducing speed, it's just to make sure that you are not overdoing it in terms of speed with your robot. If your cycle time can be 5 seconds, there's no need to program the robot to do things 2 seconds and then wait for 3 seconds. So if you use more time, you don't need the 2 seconds. You have 5 seconds at your disposal to do the task. Then by reducing the speed of the robot, you have an impact on energy consumption as well. Reducing the acceleration as well. So don't go super fast and then brake super fast, but just have a smooth movement. Increase the zone size, that's the area that you define for the robot operation. So instead of asking the robot to move in a very confined space and you have a lot of squeezing and twisting from different axes on the robot, you give more space to the robot and you can have a more gracious movement of the robot inside its working space. whoops, sorry, I try to go back. Turning off the motors and turning on the brakes. So if you are maintaining a payload with a robot arm, like a payload hanging in the air, and you maintain it on electrical power, that will consume energy. If you apply the brakes, it becomes a mechanical stop, then you don't need energy to maintain that payload in the air. So you can also consider if you have a path of the robot that includes stopping and halting in a certain position for a certain time, rather than maintaining it purely on electrical power, you might decide to apply the brakes, and that will help to reduce energy consumption as well. Like every device that we have, the TV, the computer, the phone, you have a sleep mode function on the controller that will help as well to reduce the energy consumption, or turn off the controller manually. If you know that your plant is offline for the weekends, you can just go and turn it off. You know you won't need it. And finally, see whether you really need lighting, heating, cooling in the robot environment as well. So it's like secondary or accessory to the main task of the robot, but look at whether you really need this to be turned on or not. Now, for servicing the robots, now we go into the end of life, and what do you do with the robot when the robot reaches its end of life? And are you able to extend that life further so that you don't need to buy new hardware to do the same task? So here, again, we have the supply chain that is involved and end-of-life disposal. So once you remove the robot from your production site, of course, the supply chain will be activated again. You need to transport the robot to a place where you will dispose of the robot or recycle the robot. And that disposal itself, whether you remelt it or scrap it, that has an energy consumption and a carbon footprint as well. So now we just have a short video that explains to you what we plan and what we do in regards to the end of life and the servicing of the robot. All right, so if I recap slightly what you have in this short video, I think if you walk around here today, you will see many companies offering solutions for preventive maintenance, for monitoring of different type of assets. Same goes with a robot, like it goes with your car. It's a mechanical system. It has oil in the gearbox, needs to be monitored. The oil needs to be changed the same way you bring your car to the shop for servicing. So if you are not paying attention to these factors, you are not checking the quality of the oil in your gearbox regularly, you will damage the lifetime, or you will reduce the lifetime of the robot. So by doing preventive maintenance, by taking small step in taking care of your asset, you can extend the lifetime of your asset. And if you can gain 1 more, 2, 3, 4 years out of your asset, this definitely plays back into reducing your overall footprint as well. In regards to checking how you operate your asset as well, making sure that you are not overstretching or overstressing your assets, that you work your asset beyond its original design zone. You try to go too far with a payload that is too big, for example. That plays a role as well. For those customers who are using a larger fleet of robots, you can look at how you and optimize how you use your asset across different sites. So by connecting and gathering information from the robots, you can understand which robots are overstretched. For example, you might have one plant where your robots are operating 95% of the time, but you realize that you have another site in another location or another country that has robots only operating 60% of the time. You can balance your load, provided that they do similar products, of course, but you can balance your load across sites as well, and that also helps to extend the entire fleet the lifetime for the entire fleets of your robot. Now, finally, the last two, the buyback and the spare parts. So we do offer the option to our customers to have refurbished part if they so wish. That means using parts that have been sent back for repair, rechecked, recontrolled, and reconfirmed, revalidated. So you have the option to buy those parts that are old parts that have been rechecked. And in terms of the buyback program, we are doing this. We are not buying all type of robot. It depends in which environment they have been used, whether they are really been pushed to the extreme and cannot be recycled. If they do, we have one operation in Europe that does the work of remanufacturing the robot. So we take in old robots, we recheck them, change the parts that have to be changed, and then give them a second life. So again, keep this in mind. This is not just purely about energy consumption, but there are a lot of steps that you can take when you use the robots in your factories, in your plants, that fits into this ESG concept, and that will help you have a good story for your customers as well when they come to you and ask you about what actions are you taking in terms of environment, social and governance aspect. So here, finish, you have a picture of an old robot on the left-hand side. This is from the plant that I mentioned in Europe that does the remanufacturing, and we give a second life to the robot. They come out, they look as new when parts have been replaced. They are retested as well in the full cycle to make sure that everything works correctly. And so from going back to our friend Wall-E from the beginning of the presentation, we go to our friend Yumi, which has our first two-arm collaborative robots. And for us, the vision is basically that we have Yumi working in a similar way as Wall-E. So thanks. That's the end of my presentation. I hope it was interesting. And remember all those points. Again, this is not only applicable for ABB, but all different kind of equipment and robot brands as well. And that's the steps that you can take to make sure that in your own companies, you are doing things that are in compliance and with the mindset of this ESG goals as a priority. So thank you very much.
Thank you so much to Mr. Lawrence. And of course, there's any question on the floor? Because we can see it very well from Voi to Yumi. Is it? Yeah, it's a very wonderful robot. Okay, so any questions? Seeing none?
In case you are shy, Fred
Yeah.
and Waimin, you can raise your hand. And Ang. If you are shy, you can also ask question later on to our colleagues.
Yeah. Which
At
booth are you guys?
J55.
J55.
ACE
Okay.
Engineering. Yep.
Okay.
All right. Thank you very much for your attention.